anyway. Yeah. Yeah, Joe.
Wait, our homework's
Friday. Yeah, tomorrow's just the beginning, and so quick reminder for Dean and Gavin and the rest of the class as well. Tomorrow when you come in, you're taking your endeavor fill in the blank first, and it's not, someone was like, it's over all the forevers endeavors. No, just everything starting in number, is it 14? Is that what we figured out?
What?
Yeah, it's basically all the tests, including absolute and conditional convergence, including the alternating series, estimation theorem.
14.
Okay, I think so. It's up there in the cards. We can go double check. Basically, it's the one that's after improper integrals, I think. It's the one after improper integrals. It's playing the exact same music as yesterday. Change it up.
No, I like it. It's such a good song.
It's upbeat and encouraging.
Okay. All right. Even though Dean and Gavin are loving all of our musical renditions, let's be quiet. So Joe is asking when notes and homework spirals are due. They're due on Friday, guys who are just joining us. And for the rest of you guys, make sure everything's up to date. Some of us have been losing silly points on things like table of contents. Let's not, okay? Let's just have it ready. Nice thing is, though, you don't have a book review, right? You only have the review worksheet, and then the other one is the bonus practice test, which I strongly advise. I say at least 10, because you could do all 44, 5, 6. But you could also just do 10. Okay, to that end. Section 9.6. You guys have this homework technically due today. I mean, I do have other examples that we could play with, etc. I think these are some questions that previous classes have asked in homework number, is it still 51? Oh, I erased it. I don't remember.
42.
Oh, just kidding. We're a little bit off on the homework numbering. Oh, I'm just going to, oh, there you go. Look, homework 9.6. You're welcome. Anyway, do you guys have any questions? Do we have any evens that we need to grade? I think I was getting your homework solutions open just in case. I think I have your book open, so I have the webcam pulling up. Too many to count. Well, we got to start somewhere.
We finished homework.
Huh? Yeah. Let's start with questions on the odd. That's a good idea. Let's see where we got stuck and we were able to calc chat it and still didn't know. And then we can grade the evens and see if we have questions on those. So Janelle, what do you got? 23. Anything before 23? 21. So we're going to look at 21, we're going to look at 23, and then we're going to see what other odds we have before we grade the evens. So, oh, hey, that's 29. 9.1? Okay, hold on. We're grading 9.6 right now. And I know, but that's a very different place than where we are. Yeah, so hold on to that, Lorenzo. I want to cover it, and I did ask you guys to utilize me to its fullest extent. But P.S., if you're, like, bored right now, because you're like, I aced all this, awesome. How about your worksheets? And Ryan, you can let John focus on maybe his review or his practice test or other things. Also good things for maybe you to focus on too. But you could be productive updating your table of contents. You guys don't need me to hold your hand and babysit you and tell you everything that you should be doing. Just be productive. Okay, so then we have our book open right here, and we're looking at 21 and then 23 because you didn't like them. Did I tell you you had to use the ratio root test on every single problem from homework? Did I tell you? No, I said you were allowed to technically choose. Oh, did you guys see in your book this really nice page right here? Oh, you couldn't see it because it wasn't in your book. Well, I think I actually like the handouts that I gave you a little bit better. This is a huge old summary. I don't know. It's not bad. I just don't like it as much as probably the tests that we've written in our endeavor cards. It's okay. Anyway, I'll keep the book open. If anybody wants to come take a picture of this, it's a big old summary of your different convergence, divergence tests. But I got distracted. I'm so sorry. Here we go. 21 and 23. They're right next to each other. Okay. I said you could choose whatever, but the directions in the book said, it's coming, just wait. The directions in the book said ratio test, so we'll start there. But if there is something in homework where there was an easier way, I'm totally down with us doing that because, I mean, we have a test coming, right? Where we get to choose. I'm going to go 21 up and 23 down. So, 21 up. I think they specifically said ratio test in this section, right? Okay. So if I'm thinking of, let's just actually, if you guys don't mind, go straight to the limit. I'm doing the ratio test. I have the sigma on right there. Hey guys, I love y'all, but I can't focus when there's lots of talking, and neither can other people sometimes. And I just got through honors pre-cal, and they do not know how to be quiet. So I'm only on edge because I want you guys to have a really productive class time. I don't mind you guys working together, but as soon as I start hearing it's too much, and having most of your whisper. Hey, how's it going? Yeah, I know it's not a whisper. So, coming back. I don't mind you guys working together and getting stuff done that you need to. However, please think about me and your other classes. Why am I putting n plus 1s everywhere? That's the test, and that's what's nice about ratio and root, that you don't have to go looking somewhere else and pulling some other series in. You get to use what you have. So n plus first. Why am I multiplying instead of dividing? I thought the test was division. Division of a fraction is multiplication of a reciprocal. It just saves you time. Now, what's something dangerous right here that I'm going to rewrite right now so I don't forget?
3n times 3
That's really 3 to the n times 3, right? I know, it's going to mess you up. However, now that I see that, why am I going to put the, wait, where's all of her work? Degrees are tied. If I multiply, degrees are tied. What's the ratio of my leading coefficients? 1 over 3. You see it? I have a 1 up here, I have a 1 up there, I have a 1 down here, and I have a 3 down here. Those are my coefficients. It's just 1 over 3. Yeah? What's true about 1 over 3? Oh, because the ratio root test compares to 1, whereas the limit comparison test compares to 0. It's important to have that different in your mind, right? So wait a minute, as soon as we have that, can't we just say the series?
Whoa.
My grammar and my semicolon is not proper, but that's okay. Since my terms are positive, I can use the ratio test, and by the ratio test, since the limit of the n plus first over the nth is equal to 1/3 less than 1, my series converges. Yeah.
Do you have to put like I know it's 1 over 3, but would you get it wrong if you didn't put the 1/3 and you just said like it's less
If
than 1?
you're worried, just be careful. Because if you do less than 1 and you don't show me what the limit is and you're wrong, I'm going to have to take off double. Does that make sense? But if you're right, then it'll be fine.
So you can't just put L, you have to put like what?
Well, I need your brain to somehow process what L is. Does that make sense? And so Janelle's like, I think it's less than 1, so I'm just going to put it. Because she's a little worried about putting the 1/3 and being a little off and maybe having made a mistake. The problem is, in my head, Janelle, if you didn't think about this being a 1/3, I'm not sure you would have gotten the less than 1 part.
Yeah,
So a lot of people would have thought 1.
Yeah, like not necessarily for that problem, because like I get the.
But you know that you can make mistakes and then.
Yeah, for like other problems,
Yeah.
it wasn't.
As long as you've written out the limit for me, because if you just put something like L less than 1, I'm like, what L? Like you have to write out the limit for me, like the work. But yeah, I think Joe and Lorenzo both asked me something similar way back when we were doing limit comparison, maybe, or no, integral test. Like if you can see that it converges to a constant or doesn't. But I did. Well, hold on. There were some of you on your 9.1 to 9.3 for the integral test. Was it you, Joe? That you said it converged to a constant or equal to constant or something, and then you were able to make your conclusion. I said okay, but you didn't tell me what the constant was. And then there were other people that told me what the constant was, and they were wrong. But the dilemma is technically in a free response with an AP grader. The ones for whom the limits were wrong, almost all of them had something go wrong earlier, so they would have lost the same point. Because they had to anti-derive in order to be able to make that. Like Joe had to have anti-derived to tell me equal to constant. Like if he just wrote the integral and said equal to constant, I'm like, no. I did not see that you have full comprehension of what happened. I see that you made a guess. And I'll give you the point for the test, but I won't give you the point for the work. Someone else tried to do something like that. They wrote the integral and said, oh, it's this. And I'm like, well, how do you didn't show me the antiderivative. So you need to show me, but then if you, yeah, you're right. Number 23. It's a factorial, so hopefully you guys would think of, wait, it's an alternator. tell me to do the ratio test if I have to have positive terms? You can start with the alternating series. You would need to start with the alternating series unless you went straight for absolute convergence. But you might not want to go straight for absolute convergence before you've realized it is convergent. Because if it's divergent, we'll forget it. But when you guys do a limit as n goes to infinity, what's stronger, exponential or factorial? Factorial. So therefore, we have our 0. And if you were to plug in, hey, the nice thing is we'll get our n plus first while we're at it. If we have 2 to the n plus 1, which is times 2, and if we have n plus 1, is that going to be less than or equal to 2 to the n? Yes, but not right away. Careful, did you guys just hear me? I just said yes, but not right away. Hold on, what question on the 9-1 to 9-3 quiz was yes, but not right away, and I had to take points off? Everyone's, and I gave you the point back, but still. The last one, number 9. Wait a minute. Okay, so hold on. What if you plugged in a few? Some of you were talking about plugging in terms, I forget why. What if you plugged in a few? What if I plug in 0? Okay, anything 0 power is 1, and I have 1 over, what's 0 factorial? 1's defined to be 1. Okay, got it. And then I'm going to have a minus, because now I'm going to plug in 1, so it's a negative. That's going to be 2 over 1 factorial. Ooh, this term just went up. Okay, hold on, plus. Now I'm going to plug in 2. That's going to be a positive. That's 4. That's 4 over 2 factorial. That's still 2. Stayed the same. Okay, wait a minute. It's allowed to stay the same. Eventually it has to decrease. 3. Now it's a negative. That's 8 over 3 times 2 times 1 is 6. 8 over 6 is 4 over... Okay, it's gone down. And then if I do... What am I at? 4? 4. That's a positive. 2 to the 4th is 16. 4 factorial is 4 times 3 times 2 times 1, or 4 times 6 is 24. So I have 16 over 24. I'm not even going to reduce. Guys, what do you see now? It's going down. So where was the problem? Here? No. It's allowed to be less than or equal to. Here. So what does that mean? I'm going to take this, and I'm going to say this is equal to 1 plus sigma from n equals 1 to infinity. And I'm going to test the convergence of this guy. I'm starting at 1. I'm starting here instead of there. So I don't have that weird random increase before decreasing that would happen. Now I'm allowed to say, oh, well, yeah, if you start at 1, that's good too. Which means this converges. And guys, what's 1 plus any convergent series? It's not going to make it diverge. You're just adding 1 to whatever it is. Therefore, what do I know about this? Convergent. But the problem is, even though I know it's convergent, what if there's a pop-up screen? Why did they put this in the ratio test? Because what do you need to now test or check? The convergence of the absolute value. And the absolute value says, okay, look at this guy without the negative 1. So look at that guy without the negative 1. Now I'm going to do my ratio test. My ratio test, remember, ignoring the alternator, I'm looking at the absolute value. I'm testing for, I can put like absolute question mark, right? I'm thinking about absolute convergence. I just crossed it out on accident, sorry. If I can do 2 to the n plus 1 times, and then remember reciprocal. I have to play a little bit. Remember, this is 2 to the n times 2. This one, remember, reduces, so I get 2 to the n times 2 times 1 all over n plus 1 times 2 to the n. Those can reduce also. What is my limit? Bottom wins. Bottom wins. 0 is less than 1. Anything less than 1 by ratio test, how can I finish off the problem? It converges with the alternator. It converges without the alternator. So what does that mean about its convergence? Absolute. Yeah.
For the when it's in bi-alternate series, remember too, is it like how do you know when it goes up and then like if you said
You have to plug in terms. How did I know looking at this? Is that what you're thinking? go up one in a factorial, 0 factorial is 1 and 1 factorial is 1. It didn't go up at all. But 2 to the n and 2 to the n times 2, in my head I was like, oh stink, times 2 could be a bigger jump than some of those early factorials. Does that make sense? Or it's the same jump. Oh, times 2, but then 2 factorial is times 2. So I just know 0 factorial, 1 factorial are the same, and that can be dangerous if that's the only thing that would make it decrease.
Before that, when you're taking the limit of it, can't you just do like the absolute value of a of n, so you can have the 2 to the n over n factorial, so then the bottom of n.
I am thinking the absolute value. That's true, Abby. But as I'm thinking the absolute value, I was just being lazy and not wanting to write that. I just went ahead and took the negative 1 out, which is what the absolute value does. It disregards the positive negative and just says n always positive. So that's me just using these two guys and not putting the negative 1. So this is my n plus 1. Not plugging into that because I'm ignoring him. So 2 to the n plus 1 over n plus 1. And then times just the 2 to the n factorial, but reciprocal. Because I'm dividing that by this, and so I'm multiplying by the reciprocal. Is that okay? Yeah. But you're right, I'm doing the absolute value. Well, here. I'm testing the convergence of and then I started doing my ratio test. Yeah.
Two questions. Yeah. One is absolute because it's equal to 0.
Absolute because when I looked at the convergence of it, disregarding the alternator, it still ended up converging because ratio test. Absolute value, of course, my terms are going to be positive because that's the whole definition of that, right? So I can use ratio test, not over there, but I can over here. And then, yeah, since my L is equal to 0, which is less than 1, that proves that this series is convergent. And absolutely convergent is the term that we give alternators for whom the absolute value also converges.
My second question is, how does the n factorial cancel out with n plus 1 factorial?
Remember this one, we have to go back to factorials. Oh, well, hi. I'll just have it disappear. I can show it here. When I'm simplifying n factorial all over, it's fine. When I'm simplifying n factorial all over n plus 1 factorial. Remember this one is saying, hey, I go all the way to n, and this guy says, well, hey, I go all the way to n and 1 more. So all of those reduce. So I end up with 1 over. It's a little tricky. I find that it's helpful for my brain to just think it out. Because if it was something like this was n plus 2, which sometimes it can be n plus 1 plus 1, something like that. I need to realize, like, oh, wait a minute. It's not just 1 over n plus 2, it's 1 over, I need to think about what's there. Just to be safe. Anybody else have anything from 9-6 that they got stuck on or didn't know an answer to in the odds? 25? Okay guys, I'm getting close to seeing, well actually I have it up here. Did we have any evens that we need to worry about for 9-6? I feel like we did because I have a number 30 that's chilling. Oh, we have a lot of evens. Not a lot, but we have some. Okay, we're going to get ready to check the evens in just a second. So for those of you guys that have been tuning out, you might want to grab a colored pen. You might want to grab a colored pen and be ready to go. But number 25, Abby, to be honest, we can cheat a little bit. Because isn't factorial growth stronger than any other growth?
Yeah.
So we can actually say nth term test, since the limit is infinity, which is not 0, it diverges. But you're totally right, the ratio test, because that's what they asked us to do, should show that also, right? So then, because you won't always see that, you won't have me being like, hey, here's an easier test on the test.
I got all the way to 30.
I write the 3n plus 1 is okay. And then I have my, remember he comes up top and he comes down bottom. From what AJ just asked, remember that these guys, 1 through n goes away with his 1 through n, and just n plus 1 is left. Did that make sense when I showed it? Yeah. And then I have my n tying with my n, my 3 to the n tying with my 3 to the n. So, well, wait a minute. I would have a 1/3, except I also have an n plus 1. Hold on. As n goes to infinity, all of these guys tie up. Ooh. There he is. Greater than 0 and anything. Wait. No. Greater than 1. My bad. Greater than 1. We know by ratio. And then Lorenzo, what were you saying? Oh, I was looking that way. Yeah, you're right. We could do it that way too. Sorry. And we could reduce those. Either way, we have some sort of extra n. That will make it go to infinity. Okay, let's grade those evens. Just because, let's just make sure you guys were good on the evens. Now, some of you are like, psh, I already know what the answers are. Well, okay. How? No, it's okay. Be honest. How? Nope, those are only odds. Slater has odds and evens, right? However, can I show you something, because I did not give you an answer key to the practice bonus test that has 40 series that you don't know their convergence or divergence of? Is there something else besides Slater? Because Slater won't have my random worksheet, will it? Maybe. If you were to go online, and if you were to look for convergence, divergence, there's a convergence divergence calculator with steps?
Oh, I'm not smart enough.
Do you guys know there are integral calculators and derivative calculators? And I mean, you can use Wolfram, that's one, but there are others also. There's something called a series calculator. I think this is the one I like the most. There is a Wolfram Alpha, but you have to get the widget. I don't know if I like the other ones. The Symbol Lab is usually pretty good. Meaning, if we go find the first one, oh my goodness, derivative and limits, and it has math type to make it nice. Oh my goodness, it's ready to go with easy ones or basic ones. If we were to do like our first even, and our first even was, I don't even know, what was it, number 6? Well, you're matching a graph on that one. 6 is C, 8 is B, 10 is E. You would have had to plug in the first few terms and then think of E as being 2.71828. Number 52, though, for instance. We're going from 1 to infinity of 100 over n. Sorry, wrong way. Where am I going? Over here. I'm going from 1 to infinity of, you can come up here and grab a little, oh, where is he? That's okay. Is it 1 over n? 10 over n? 100 over n. You can just use a division sign for your calculator. Those of you guys that have been using WebAssign for physics, it's pretty similar. And then you can throw it in and be like, what does this tell me? Diverges. Oh, I could do this with any of the ones on the worksheet and know whether or not I'm right. Now, hold on. Wait a minute. Is the main point, are all the points just whether or not you guessed the right one? No. So you know that from the quiz. So, wait a minute. Do we necessarily like their steps? Cauchy's convergence condition? What? Who's Cauchy? We could hide the steps and see some random person shaving their legs. Hi, ads. Hide the definition. It's kind of like, But do you see how maybe this calculator is solving it a little bit different way than I am? Now, this one is a simple harmonic. It's what a lot of people memorize. So maybe it's just this one where they're like, duh, it's 1 over n. Let's go try another one. What's another even that you guys had? So P.S. number 52 was diverge. Number 56. Let's throw in 54, though, real quick. So 54 is still from 1 to infinity. Let's see if we can go back. There we go. But this time it's of... let's go grab our 2 pi. How do you do pi? Pi. 2 pi over, what do we got? Keep on going the wrong place. 3? And then raised to the power of, use your little baby caret. Ooh, that's nice. N. Oh, I guess we could come up and actually see if there's a pi. I guess we could be nice and actually see if there's a pi. Just kidding. There's one right there. There you go. Boop, go. Is it going to tell me why it's divergent? Oh, look, it knows it's divergent. Apply the ratio test. Well, I mean, that's cool and all, but what about the geo series? Wasn't that easier? So are they going to necessarily tell you the easiest test? No. You could also do the nth term test because 2 times pi is bigger than 3, so then the limit is infinity, which is greater than. But they are going to try to give you at least some sort of test. They are going to try to give you some sort of test. But then in this one, guys, if you realize they just sent me to like a tutorial to relearn the ratio test. They're not really showing me the steps. So this one is good. The symbol lab is good for typing in, I think, and for getting the convergent divergent. Wolfram alpha is probably a little bit better as far as having a bit better work. That's fine. Oh, I don't want examples. Sorry, Los Santos. I want this one. Because you can ask something to the effect of, and you might actually just be able to go find, does it actually have, I think it's easier to type it in. Test the convergence of the infinite series 2 pi divided by 3 raised to the n. From n equals 1 to n equals infinity. Now, if you guys notice, there was a widget that showed up just a second ago in our search. So it might be easier rather than going to the normal Wolfram homepage and typing in something similar to what you just saw to try to go find that widget. Did I spell it wrong? Oh, convergent. That's why it's so confused. Thank you, thank you. There we go, opening the widget too. But anyway, all that to say, I'm not making like an answer key to those 40 series. I just gave you 40 and said, hey, play with them, find yourself 10. Here's the widget, so they're actually giving like determine the convergence of. It's a little app basically that someone's made. But you do have to type that in as far as 2 pi divided by 3 all raised to the nth power from n equals 1 to infinity. But once you have that, you can see what it comes up with, and then this is what the normal screen came up with. Still doesn't like me very much. Probably the widget's the best way to go then. Oh, look, it gave me the easiest one. Well, nth term test, yeah, maybe Lorenzo. Maybe that one would have been easier, but Geo series is pretty easy too. But once again, it's not walking you through all the steps, which is a little annoying, but it can at least give you a direction. I'm going to let you guys grade the rest of the evens. So we know 52 diverges, we know 54 diverges. Lorenzo, what's your question as I keep scrolling? Okay, let me freeze the screen so people can keep grading. We have up here our 56, which diverges by the limit comparison. Ooh, by the limit comparison. Yeah, that's an easier one than probably anything else. Compared to 1 over n, the degrees are tied. What one does, the other does, and 1 over n diverges. Anyway, let me freeze the screen so you guys can grade it. Let me go find the one that Lorenzo doesn't like, which is 9.1, number what? 59. That was sequences. Not series. Where were you all? Ah, DNE. Why is it DNE? Monotonic. Oh, we're supposed to be answering the whole whatever. Sorry, I thought we were checking the limit. Oh, the limit's 0. Okay, monotonic is a word that we saw last year in CalcAB, and monotonic means monotone, all one tone. Monotonic, all one behavior. Not constant necessarily, but all one behavior. Always increasing or always decreasing. always increasing or always decreasing, meaning it doesn't increase some of the time and decrease some of the time. And so when you're looking at number 59 with these directions, let me get rid of this real quick. Monotonic. What happens as you plug in n equals? What happens as you plug in n equals 1, n equals 2, n equals 3? It's sine of pi over 6, or 2 pi over 6 pi over 3, or 3 pi over 6 pi over 2. It's going to cycle through all the sixths, thirds, and halves, right? And as it cycles, doesn't sine, wait, sine's always bounded because it can't go above 1, can't go below negative 1, right? So bounded in that sine is not going to infinity in any way, shape, or form. It is stuck within a range of negative 1 to 1. Bounded, yes. Monotonic, oh no, sine goes up and down and down and up and up and down and down and up. Yeah, oscillates. Good. So since it's not monotonic, it's not strictly increasing or strictly decreasing, it's oscillating, and since and even though it is bounded, the limit would not exist if they were asking you. But they didn't ask you to take the limit, huh? No. Bummer. I think I was wanting you to take the limit. The reason I was wanting you to take the limit is because this is not an oscillator, right? Because pi over 6 is in the first quadrant, positive. 2 pi over 6 is in the first quadrant, positive. 3 pi over 6 is at the axis, positive. 4 pi over 6, 5 pi over 6, 6 pi over 6, positive, 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 or 0. 7 pi over 6, negative. It's not an oscillator. It's not going back and forth. Cosine of pi n, yes, without the 6, will be positive, negative, but sine not. And why would the limit not exist of this guy? Yeah, because it's going in between fixed values. It's not getting closer and closer to 0. It's not decreasing. I mean, sometimes it goes down, but it's not eventually decreasing, or the nice word, stabilizing. It's not stabilizing to any single constant. So the limit doesn't exist. That's why I like this term. And it's not oscillating. But yes, it is bounded. It's stuck in between 1 and negative 1. Not monotonic because it's going both up and down. You could take a derivative and then check the sign of cosine of pi n over 6 times pi over 6. Can cosine be both positive and negative? Yes. So therefore my function is both increasing and decreasing. John? Yeah. On the, which one? The Thursday one?
Yeah.
Got it. The one with 12?
Yeah.
Oh, nice. It's an arctangent. U is n squared. Pause. What did my brain do? My brain thought n to the 4th plus 1. My du would be 4n cubed. I'm like, oh, I hope not. Then my brain said, wait a minute. U squared plus a squared is tangent inverse. N squared plus 1 could be n squared squared. Could be tangent inverse. And then who's du to n squared? 2n. Now, hold on. Du, I mean, technically we're not supposed to be taking an integral in terms of n. Some of you guys lost points on this on the quiz. We're supposed to be considering the function x over x squared, sorry, x to the 4th. So maybe you didn't show b going to infinity, or you did like b going to infinity with, I don't know, just check your work. But I would do have the x dx, no big deal, it's just 1/2 du, so I'm going to have a 1/2 of, and then I'm going to have a 1 over u squared plus a squared, and a is just 1 du. That's the definition of arctangent, so 1 over a tan inverse of u over a. And so as I plug in 1, and then my 1/2 be in front. As I plug in 1, tangent inverse of 1 is pi over 4. Tangent inverse of b squared over 1 doesn't really matter. Oh wait, going to infinity, but tangent inverse is bounded. So I would have my,
So this whole thing is a constant.
this whole thing, you don't even have to go farther, you can say is a constant. And since my integral converges to a constant, my series converges, some of you got this wrong. My series does not converge to the same constant. The improper integral is not the same value as the series, because the series is plugging in positive integers 1 and 2 and 3 and 4. The integral is accumulating everything with the infinitesimally many values in between 1 and 2 and in between 2 and 3 and in between 3 and 4. They are different. But if this improper integral converges, then that guy has to converge. He's like kind of like the bear squishing in, Abby squishing me in, similar idea. So I can just say it's a constant, so therefore convergent. Joe, what's up? Sorry.
I have a question. So, let's say you just have a series with the 3 inside, right? 3 as the argument.
Nth term test, divergence.
Yes, but why doesn't the root test work? Because if you take the root test, then it would approach 0. But we know that
No, it would approach 1. Because the n plus first would be 3 and the n would be 3, so the test fails. Because it's just 3, 3, 3.
No, you take the nth root.
Oh, I thought you said ratio. I am so sorry. The root. The root test.
Equals to 1, so you have to use other terms.
Yeah. That's okay.
Which is a different
Some things happen similar with those of you guys that said limits were equal to 0 when really it was ln of something equals 0, so e to both sides is a similar mistake. You saw this, right? It's wrong place. Yeah.
When you take the limit of the infinite,
Yes.
is the 1 over 1 like?
That's me using the tangent inverse formula of 1 over a, tangent inverse of u over a. But in this case, my a was just 1 squared. If it was a 4, then that would have been like a 2.
Oh, so it would have been 1 over a.
1 over a. So if it was like a 4, then a would be 2 because a is squared. And so that would be a 2 and this would be a 2. So I was just reminding you guys of the integration rule when I did that. Yeah. Anything else you guys want to talk? Oh, hints. Hints for the part of the test tomorrow. Is that okay? Yeah, there you go. I was like, maybe. Okay. Take my keys. That's why I'm holding them. All right. Tomorrow's portion of the exam, similar to the first part of the review. But the first part of the review, isn't there some multiple choice and some long answer? Or not long answer, but still. Okay. So be aware for the part of the test that is going to be tomorrow after the endeavor fill-in. Endeavor fill-in, remember, you don't have to state any one entire card. But I am going to have different convergence, divergence, vocab.
Is there bonus?
Yes. I don't remember what it is, but there's something to bonus. But I'm just going to have you guys filling in blanks. Like, I don't know. Limit comparison test, L is greater than 0. Then blank. And like you just fill in. Yeah.
Is the bonus like showing up in data cards?
I think it's all only things that are applicable to the chapter that we're in. So no like crazy MBT, IBT. However, what you guys should probably be a little bit more concerned by. Oh, hey, bonus. Oh, the bonus is built in. The bonus is built in. I have 11 points possible, and I'm just taking it out of 10. So if you want to think about it, one of the beginning limit rules.
There's 11.
Did you just hear what I just said?
Yeah.
Special convergence.
The 1 over
Special case.
all those things.
You can think of one of those as being a bonus. I guess those blanks are 1 point. You can think of that being a bonus, but those are half points. Anyway, but guys, the things that you're filling in are the thens, the conclusions, the ifs, what leads to that conclusion, the ifs, what needs to be true for a test to apply. What you're taking the limit of that gets you whatever it is you're trying to find. But anyway, yeah. But I also told you guys special convergence sequences. But the part of the test you're going to see tomorrow has 1, 2, 3, 4, 5, 6, 7, 8 multiple choice and 3 fill-ins. 8 multiple choice and 3 fill-ins. One of the fill-ins is determine convergence of a series, kind of similar to what John just had me go over. One of the fill-ins, there's 2 more, The other two have to do with the alternating series estimation remainder theorem. So do you remember when in homework we had to do things like within a certain error? Or how close is an term, an nth partial sum approximation? So there are three fill-ins. Two of them have to do with the error. Two of them have to do their alternating series. So it's using the theorem like we saw in homework and you guys asked about. Now here's something for you guys to realize. Hold on. If they ask for error either less than or within, is it allowed to equal? No. So if you solve for how many terms you need equal to that number, you would have to go either above or below, depending on what statement you get, whether it's an eventual greater than or eventual less than. You have to go one in to the interval in order to get the within. So if it's less than or if it's within, hint, both of them are. If it's less than or if it's within. If it's less than or if it's within, you have to get within the actual interval. And the third one is just like converge or diverge. And then you have those 8 multiple choice. And those 8 multiple choice are anything from, hey, this guy does this, so direct comparison, who else does this? Or if this is true, what does that mean for all of these guys? Or which of the following failed the test? Or you're using this test, which of the following would make it converge? Or which of the limits would make it diverge? Which of the following statements are true? Not all of them are necessarily doing convergence or divergence. Some of them are just kind of like making you work through the test a little bit more. There are 1, 2, 3. There are 1, 2, 3 of them that basically give you 4 to 5 different series and say, hey, which of these diverges? Which of these converges? Which of these diverges? Which means you're going to have to do a lot of tests pretty quickly. Does that make sense? And do you necessarily have to do a test for every single one? No. Can your brain kind of be like, oh, hey, look, that guy enters test, he fails. Of course he diverges. But just kind of, it's going to make you hopefully go fast or go fairly quickly on your analysis. Now, guys, in the multiple choice, you need to show me like gorgeous work. No, I hope that you can make a legal deduction as to which one converges, which one diverges. On the multiple choice long answer portion of the test tomorrow, my advice would be to start on the multiple choice. Because the long answer and the error, some of you are going to really get bogged down. So if I were you, I would totally work backwards, and I'll remind you this tomorrow. I would work on the multiple choice, and then on that convergent divergent test, it's just like, whatever, I'm supposed to do tons of these tomorrow, and then the error. Unless you want to just practice that error a lot tonight, and then come in and be like, I'm going to do the error ones first, and then just have them done. But typically, historically, kiddos get a little bit stuck on the error, and they're not worth tons of points. Like, remember, there are a lot of points on this test between the 2 days. Not that you want to skip the error, you want to show as much work as you can, but don't let yourself get stuck there tomorrow. Any questions? Okay. Tomorrow's going to feel a little bit normal, except this is the endeavor and then the test. And then Friday's going to feel weird, but that's why I'm trying to have you guys prepare. Pause. The one that John had me do just a second ago. Oh, no, that wasn't the right one. What was I want to use? There were like 3 different tests that I was using in it. I forget which one it was. Oh, this one. I used alternating. I used ratio test. And I guess that was it. Could this one, number 23, could it have counted for both? No. Could I have counted it as a ratio though and circled ratio? Yes. Or could I have counted it as an alternating? Yes. If this was my alternating, could I do a different alternator but just use it for a different test? Yes. If this was my ratio, would I have to do another alternating? Yes. Does that make sense? I hope so. I hope so. It's really sad when it doesn't make sense and then kiddos just get messed up. But I love this because it makes you look through on Friday and pick out like, ooh, I know what test. Ooh, I know what test. Ooh, I'm going to try. Oh, it didn't work. I'm going to try another test. And it gives me an opportunity or a way, without telling you what test to use, to make sure that you show me understanding of all of them. Bye guys, I'll see you later. Oh, accreditation meeting right after school. I will not be here. But I will be here lunchtime, 3 to 7, or tomorrow after school. Yeah. Preparation for Friday. Sorry that I'm Friday. That was tomorrow. The packet is just this one. And it's by Friday with a toner. And it's once again just showing work on the 10th.
Oh, it's not the battery?
Because in multiple choice, that's what you need, right?